good morning, and very good morning. Welcome to the show. Welcome to Viewgraphy. Okay, so today topic is okay. Before we start today topic, first of all, really apologies. I was kind of busy lately. Not many videos on the air for the YouTube, but I'm just trying to keep it up. Anyways, so there was a status, Facebook status I put. I'll show you on the screen right now. So I put that status, and people start, getting questions, asking questions about infinity and focus, depth of field, blah blah blah. But, but there was one interesting comment I received, and it says that uh, at infinity, every lens got a sweet spot. So infinity, even if you focus at infinity, so even if at 5.6 or f22, depth of field matters, and you won't get that sharpness, and things are in focus. And so there was kind of people misunderstood what I was trying to say. What exactly? First of all, you have to keep these two terms, which today's video is all about. One is focus, one is sharpness. Okay, people most of the time getting confused. Like they think is if it's uh, focus means sharpness. That's not the case. That's not the case. Uh, if it's uh, if it's in focus, it's not necessary the image has to be sharp. But in order to get sharp focus, it has to be in focus. Like in order to get sharp image, it has to be in focus. But if it's in focus, it's not necessary that the image can be sharp or not. Let me explain you how. So keep the focus and sharpness separate. This video is all about to clear this concept that focus is all about depth of field, that how much area you will get in focus, and sharpness is totally different thing. Sharpness is the characteristic of a lens. Okay, first of all, let's talk about depth of field, and I'll talk about sharpness. So depth of field basically depends on three primary things. Like if this is a camera, okay, if this is a camera and this is a person you are shooting, or any object you are shooting, and you focus, like let's say you focus at f4, all right. So from this center point, 1/3 area will be in the front focus, and 2/3 area at the back of that subject will be in focus. So your camera is here and this is the subject, so 1/3 area will be in focus and 2/3 area at the behind of that subject. So that's the overall area will be somewhere like this. So that's how depth of field works. So depth of field basically depends on primary three things: uh, focal length, aperture, and shooting distance, like how far or close you are shooting. It's very easy. First, the focal length. So the smaller the focal length, you will get everything in focus. Okay, the longer the focal length, let's say 85 millimeter, 100 millimeter, 200 millimeter, 300 millimeter, 500, 600, 800. So longer focal length, small area will be in focus. Smaller focal length, everything will be in focus most of the time. That's why for landscape you need wide angle lens, 14 millimeter, 12 millimeter, something like that, to get everything in focus. Most of the things in focus. So focal length, small focal length, everything in focus. Large focal length, smaller the area in focus. Okay. Then we have second thing called aperture. Aperture, everybody, most of the people knows, I am presuming. A smaller f number means small area in focus. Larger f number means large area in focus. Straight away. than shooting distance. If this is the subject and this is the camera, so the close you are going to shoot, the less area will be in focus, even with the same focal length, with the same aperture. If you are shooting far, then large area will be in focus. So if you keep getting close, the area in focus will keep getting shrink. The far you go, okay, so the everything will be in focus. That's why when you shoot landscape, you try to focus somewhere far, so most of the area will be in focus. And that's why if you are shooting portrait in a close proximity, you have to make sure like you need close to get the background blur, so you get shallowed up the field, narrow area in focus, so everything behind of the subject will be out of focus or blur if you're taking portrait. So that's how depth of field works. So that's how depth of field works. But now area and focus works. Now what about sharpness? Sharpness is a lens parameter. Sharpness is basically define the RGB value, which the three rays coming into the light, white light composed of RGB. So when the three light comes into the glass, okay, so whatever the focus will be, if this is the sensor and this is the lens, so when the light is coming from the lens, passes through the lens and hit on the sensor, the all three RGB's value should be falling right at the same spot. Then you will get the perfectly sharp image. All the three RGB component of the white light has to be fall exactly on the same point at the same time, to get the image perfectly sharp. Now why I said time? If it's falling on the same point, yeah, it sounds logical, but what about time? Time is basically necessary to mention, but it's more kind of a technical thing, but still I'm going to mention it brief. The glass is an insulator, alright? Glass is an insulator. It always try to stop the light, alright? So imagine this is the glass, and if the components of the white light, which is based on three components RGB, if these three components go inside the glass, try to pass through it, glass has a tendency to stop those components of light, because light composed on three primary colors, red, green, blue. So the glass always try to stop one of those three components which got higher energy capacity. Now, how do you know which of these three got higher energy capacity? There is an equation, I'm going to write it over here. Mu is equal, energy is equal to nu, Planck, which nu is the Planck constant multiplied by speed of light. Alright. So, the energy, and if you look, these three components RGB, which is infrared, then red, yellow, green, and then ultraviolet. So the red is always has a small frequency, and the blue always got higher frequency. So when you got to put these red small frequency into this equation, the energy will come, the answer will be a small number. So when you're going to put the blue frequency into that equation, the answer will be higher number. So the higher number means the glass always try to stop the higher energy capacity, higher energy component. That's why when you try to pass these RGB values through the glass, the red and green easily going to pass through, the blue always gets stopped because of its high energy capacity based on this equation. So that's why when you pass these three components from the glass, the red, infrared, yellow, green, these components easily pass through without any issue. But the ultraviolet, the blue, cyan, and violet, they always get hurdle. The glass always try to stop these components of the light. So that's why they land in a different point of time over the sensor. So the red, green will always comes first and blue always reach late to the sensor. So that's why there is a phase shift and you won't get that sharp images. Yeah, I know it's kind of too much technical, but I'm just trying to share with you the idea of how sharpness works. So, what basically how to combat this situation? What these Nikon, Canon, Sony, Fujifilm, what they are trying to do, especially I'm going to mention Carl Zeiss because Carl Zeiss do a very magical thing. What they do, they put lead element into manufacturing of the glass. What lead does, it basically make it makes that glass kind of oily in nature. So whatever the light comes, it just slips. It just slips without any restriction, without any hurdle. So that's how they mix the chemicals into the glass, which helps to slip the light, especially the blue light and the violet light, which according to that Planck that equation always try to get stopped. So they mix the lead and other chemicals, other radioactive chemicals into the glass, which helps these components to slip through the glass and reach all these three components over the sensor at the same time. That's why, remember those old classic glasses from Carl Zeiss, which was having that special character, special bouquet, and all that. And these are all because they were manufacturing the glass elements in a different way, not the regular way what we seen today. So Carl Zeiss is number one when it comes to producing those special glasses. So now you know how the sharpness and the overall look of the glass made. So different number of configuration, glass elements, type of glass that been used, you achieve a sharpness into the lens. But this is completely different from the focus, area and focus. So now let me explain you why the focus and sharpness different. In order to get any image sharp, it has to be in focus. It must, because if it's an out of focus area, it's never going to be sharp. That's basic understanding. But if the subject is in focus, there is a probability, and it's a very high probability, that there is a chance you will never get image sharp. Why? Because when you press the shutter release button, the camera shakes and you get micro blur. I made a totally dedicated video about micro blur, which I'll put somewhere in the card over there. So you will see that why micro blur is really important. Higher the number of megapixels, the more micro blur you are going to see. The smaller number of megapixels, the more forgiving your camera is, and you won't able to see micro blur. So after 33 megapixel, you start seeing micro blur very much. That's general. Up to 24 megapixel, you won't get notice those micro blurs, but after 33 megapixel, especially 40, 45, 50, 60, 61, it's very evident. It's very prominent. You will get micro blur all the time. So even the subject is in focus, but still, because you press the camera shutter, camera shakes, micro blur was introduced. Or if you're shooting a portrait or person moves slightly, you never get sharp images. Or there could be any other way. For example, you put the camera on tripod, wind blows, and because of some way the tripod got a little bit shaky and you were taking long exposure, image is not going to be sharp of the rocks or the landscape that you are shooting. See, there are many ways that you will never get sharp images even if it's in focus. So the focus is completely different than sharpness. Sharpness, of course, to get a sharp image, it has to be in focus. But it's not necessary that if it's in focus, it has to be sharp. It's not. Probably your lens is not sharp enough, or you have the focus element in the lens misaligned, or you got micro blur, or you could be any other reason. You are using old lenses which were not clinically sharp but still get certain characteristic in it. Carl Zeiss lenses. The Zeiss lenses were never sharp much, but they always have a certain character. Leica lenses have different, always had a 15 millimeter 1.4 Leica lenses, very famous. Those 50 millimeter have always have a very unique output because of these Bayer filter. Like I use a special Bayer filter, and like I use different type of glass elements made from which are manufactured using a different kind of chemicals like lead, I said. So all the combination of filters like weak color CFA and different glass elements, number of configuration of glass elements, and the number of different elements used to make those glass elements, all this. So Leica use the combination of this feature to make a certain look and certain sharpness. Well, there is no such thing as certain sharpness, but there is one thing, yeah, called sharpness. I have a lens from Pentax, 6:7 format. 6:7 is like this big sensor. It's twice the size of full frame. Yeah, 6:7 format sensor is twice the size of full frame. Yep, twice the size in the width, twice the size in the height of full frame. Okay, so I have that lens 105 f2.4 from 6:7 format from Pentax. That lens is not sharp, but it is very sharp. How come? When you take an image which is in focus, and you take an image, you've seen the viewfinder, even you go to, uh, you know, try to get perfectly sharp image by going to the back of the camera LCD, digitally zoom, and you manually focus. You see perfectly sharp. You click, it looks sharp. When you zoom, when you see the image 100%, image looks sharp. But when you go to 100% zoom, the image is not sharp. Never sharp, like most of the time. But when you zoom out, it looks sharp. So there are those things. The way lens design for these kind of lenses, that's the maximum sharpness that they can provide. Like if you compare with the Nikon Z lenses or Canon RF lenses for the mirrorless, those old 6:7 format not even close to these Z lenses or Canon RF lenses or those Sony G Master lenses. They're not even close. All the G Master, Z mount, RF mount, these lenses are so sharp, clinically sharp, but they are not having those certain character which those 6:7 format lenses have or Leica lenses have. Why? Because lens design, I mean, it's a compromise. In order to get a sharp lens, you have to sacrifice over certain parameters, which I'm not going to talk in this video. It's a total separate topic. It's a big topic to discuss, but we'll leave it for some other time. So, sharpness. It's again, it's it's an attribute of the lens. It has nothing to do with the camera. Of course, you have to subject in the area of focus, in the depth of field. I didn't use depth of field much in this video because it's all about area and focus. If it's in focus, it's not necessary if it's in focus it has to be sharp. No, but in order to get sharp it has to be in focus. So that's the whole idea of this video. I hope you understood by now what's the core message in this video, and yeah, that was an interesting question actually. Keep asking me such questions and we'll make videos about it for you guys. We have a Facebook group called Viewgraphy, just like this Viewgraphy YouTube channel. You write on Facebook, VUEGRAPHY. You will get that Facebook group. Join in, and where we have there we have lots of technical questions and Q&As. People share their work, which is not much, but still. I always try to keep the content, or the quality of the content. Actually, that's what I was trying to say. The quality of the content on the Biography Facebook group, top notch, like really top notch. So basically, in order to get images approved, it has to be exceptionally good. That's what I'm trying to do, because it pushes you to go beyond your boundaries to get something. I hope you got my point. Thank you very much for watching this video, and I'll see you guys in future with some new content. Till then, take care. Bye.